we are under the dome of Dallas Hall, and as you've seen, there's a theme of symmetry that runs through a lot of our stops here on campus, and it has its culmination here in the dome of Dallas Hall, because this is one of the most symmetric structures that you'll see in the entire campus. Now, how can we tell that? We can look up at the dome and we think about how far do we have to turn so that the rose window in the center of the dome appears the same as it did when we were standing in the original location. And with this space, you only need to turn 1/16 of the way around the circle, just 22.5 degrees. Because if you look at the window, there are 16 identical sections that it's divided into. And you'll actually see this type of window called a rose window adorning, for example, churches all over the world, divided up into lots of different numbers of symmetric pieces. Sometimes 16, sometimes 24, all sorts of numbers occur. And although this is not a church, it does help to give this a feel of a temple dedicated to learning. And we can use the symmetry of that dome to understand more about the patterns that we see there. For example, suppose we wanted to count the number of the pink eye-shaped motifs that run around the outside of that rose window. Well, it would take a while for us to count them all the way around that circle. But we can actually use the symmetry, and we just look in one section, and we see that there are 3 of the small motifs in that section. We know there's 16 sections, so 3 times 16 gives us 48 total of the small pink designs. The pattern extends down throughout the entire dome. You'll see that every part of the decoration of the dome has that same 16-fold symmetry. So for example, if you want to look at the number of scrolls around the outside, you see that in each section there are 7 of them. And so 7 times 16 will give us 112. That was pretty quick and easy, a lot easier than counting all the way up to 112. You can even count the number of little wooden rose patterns around the very bottom edge of the dome. There you'll see there's 9 in each section, so we have 9 times 16 is 144 little roses that they had to carve in order to make this dome. So in fact, because of the symmetry, we get a linear relationship. If S is the number of items in one section of the design, then the total number of items all the way around the pattern is going to be T equals 16 times S. And as you'll probably recognize, an equation of the form T equals 16 times S gives you a linear relationship. So this is a case where the symmetry actually produces a linear relationship. Now, if you look a little closer, you'll see that in every individual section, there's almost always an odd number of whatever motif, 3 eyes, 7 scrolls, or 9 of the roses. Why is that? Well, if you have an odd number and you arrange them evenly spaced within that one cell of the pattern, then there's always one that's right on center, and then an equal number on either side of that. So they're naturally arranged symmetrically within the wedge of the pattern. And if you look at a motif in the pattern where there's an even number, for example, the shields around the very bottom gold, you'll see there's 4, but you'll notice that they're not equally spaced. Why is that? There's extra space in the middle so that, again, the 2 pairs on either side are symmetrically arranged around the center. What this is telling us is that each one of those 16 slices itself has mirror symmetry. So there are 8 different mirror symmetry planes around the whole circle, and that actually divides the dome into 32 identical sections. Just half are mirror images of their other. That's an incredible amount of symmetry, and it all sums up when we look up at the dome to a sense, wow, that's beautiful, and that's what symmetry is doing for us.